we will work on things that we can solve. The other thing we leave aside. So in a sense, scientists are much more, science is less exciting and less inventive. It's inventive within borders. It's inventive in the way of solving puzzles, not inventing new ones, or new theories. It's not like the romantic view that scientists just stand in front of nature, alone maybe, and even in the night, and just for Newton, and see one apple falling and another, and see and suddenly come up with Newtonian gravity. It's not like that. Scientists work, within a certain paradigm. They are taught what to think, in a sense, and how to think. Of course, there is some inventiveness, but within borders. And they are pretty limited, these borders. And people who don't follow that are punished. Either by not getting good jobs, not getting good grades, not getting good publishing and so on. So it's more dogmatic. Science is more against, this view of poker and positivist in a sense, or received view. Science is much more dogmatic. It's not better because it's not dogmatic and critical. It is pretty dogmatic, most of the time. Normal science is in a sense, the default. Students are taught the paradigm without being encouraged to question seriously. You can ask about the details. That's okay. You can be a good student actually if you challenge the details, the small details. But when you try to challenge the big paradigm, that's not acceptable. And indeed, what Kuhn argues is that, for instance, Newton's paradigm, it's not that there were no problems, there were problems right from the beginning, but it survived 300 years. It was developed in different ways and so on. So, debates about fundamental depths, you would say nowadays in science classes that these are philosophical debates. But it's really a debate about paradigms. And these debates are not encouraged. And textbooks reflect the paradigm. That's really important. They are not open-minded, say, well, there is one paradigm, there is another one, and let's have one chapter for one, the other. No. There's nothing like that. Either the other paradigm are not mentioned, or they look down at it, or just mentioned in a footnote or something. Yeah, they talk about other paradigms, but all these other paradigms are not the original paradigms. They are according to the new paradigm. They're presented. It's not that a book on general relativity would not talk about Newton's theory, but it's not the original Newton's theory. It's according to the new paradigm. It's not recognizable in Newton's principia.
All the reason they don't say of one clear winner, right? They're not talking about the character that they believe in. So a lot of them are like that, they see the sort of scientific matters much more so than in physics and or like Mai's, where that's just the relation and the question. Right? So for example, we have emotions, and it says that either the emotions can be one theory is that the body consists, and one theory is that your mind consists, or it's a combination of both. Right? And there's no
So for Kuhn, and again, it's not that Kuhn's philosophy is watertight. It's controversial. It has been very influential, but also controversial. For Kuhn, such a situation is a situation of paradigmatic science. When there are different views that are mentioned and so on, it means that it's press science in some sense. So either psychology is not mature enough, or that this is actually, kind of bluffing because it's putting it in the language of the new paradigm. Maybe the new paradigm is like that, the way you do therapy is more open. You don't do according to being Freudian or something like that, and that's part of the new paradigm. So the history of science is rewritten in this textbook and other articles and things that so according to the description of the paradigm, the theories of the paradigm, according to the education, and according to the way the paradigm rewrite the history is bound to be within normal sciences. Because it's always portrayed as linear. The old theories are described from the new point of view as like anticipating, or the beginning, or something like that. So the new theories are just kind of twist or development, or making it better, and so on. But Kuhn says that if you look at the history of science, as a historian of science, or sociologist of science, you see that that's not the case. But this is kind of this is a rewriting of the history. Okay, so prices. At some point, the puzzle solving activity leads to more and more anomalies. The more the theory develops within the paradigm, the more it says about the world, the more chance there is that they will disagree with the facts. There are more and more puzzles that are not solved, and they accumulate. And again, because the paradigm is not flexible, it's relatively not flexible, according to Kuhn, it's bound to try to answer all these questions and puzzles according to the paradigm and not according to other methods. So it becomes less and less possible to solve the new puzzles, and more and more difficult to solve them, and they accumulate. So more and more seem to be intractable. Before it was like that they are difficult, we have to wait, it's not the time to deal with them. Now they look a little bit impossible to solve, and there is an atmosphere of crisis. So it means that the grip of the paradigm is not as strong as it was before. It's not that the problems themselves changed in any way. Not necessarily. They might be just the same problem, but there is a new perspective on them. The scientists suddenly become to be more skeptical. And that's because they have less belief in the paradigm. So the anomalies that before were kind of, let's wait, are conceived as more and more challenging to the paradigm, and not the problem of the scientist, the problem of the paradigm. So more and more problem to the paradigm. Yet, even in this crisis, scientists don't change alliances or throw the theories. They need an alternative that they will find as attractive. Scientists don't change the theories even if there are a lot of problems in these theories, unless they have an alternative. So it might be that the crisis will be actually long. And then at some point there is a revolution. There is a new paradigm that looks attractive and introduces more and more scientists to go with it. And there is a shift to a new paradigm. That's a revolution. So examples of crises where Newton's theory could not explain a number of things, and then there was special relativity at some point. But it was after a relatively long crisis. And other examples are, so for instance, And special relativity is a very different paradigm. This is an example of the twin paradoxes. So if you have a twin, one stays on Earth and the other one goes very fast in a satellite and come back. Because the one that comes back really is older. No, it's actually younger, sorry, than the one that stays, according to special relativity. So it's a very different conception of time. Other example of a paradigm shift is general relativity from Newtonian theory, quantum mechanics from classical physics, and so on. So, scientific revolution, according to Kuhn, are relatively sudden, like political revolution. It could be a long crisis and then suddenly happens. It's very difficult to predict when it's going to happen, but it can happen. And then there is a shift to the new paradigm. And the shift, as we said, is not rational in the sense that it's not that they talk gibberish, but they cannot, the parties that debate how to proceed in a crisis, they have different views about what is rational and what is not, what is important, what is not. So in that sense, there is no rational debate in the sense that everybody can agree on common criteria for the debate, how to decide. So there is no, during the crisis, a decision, in which theory to go for, how the revolution would happen. There is no agreed canon or methodologies that constitute the basis for such a debate. It's more like a start shift. Suddenly you see things differently, and you go to the new path. But you know that. But you can see this in two different ways. So this picture, for instance, two different ways. So the way the scientists suddenly see the world that they saw before, in a different way. It's the same world. It's not that the world changed, but they see it differently. That's their approach. Then there is a new normal science, and the new normal science portrays the revolution obviously as a rational, as the best thing that happened, and more progressive and so on. And massive reconstruction of the history of science, new textbooks and so on, and so on. So we have all these examples. And students are taught the new history and the new, according to the new paradigms, and they have, that's the reason why they have a conception of linearity. And then, as we said, this cycle just continue, and that's what happened. So this conception of science, has been very, very influential. Kuhn's philosophy has been very, very controversial, and people attacked it in different ways. But the result, the end result is that nowadays there's a different way to do philosophy of science, and different way to write histories. So there is much more emphasis on cultural and social factors in understanding science, and it's more, so to speak, relativist in the sense that people think about less in absolute terms about science, and less about science as the science of geniuses, like of genius people, and that science is linearly developed, in an objective way, in a rational way, and so on. There is more and more understanding that different eras, that different science, so there is more and more understanding for the fact that Newton, for instance, was also religious and was alchemist, and there is an attempt to understand this science in the context of being also an alchemist and religious, and not as something that is working, but as something that is actually very natural for someone like Newton, and it's part of his overall thing. So there is a different way. People would say that there is an attempt to look at the history of science in less anachronistic way. To try to understand the science within, its culture and historical era and so on. So if you are interested in this, for instance, there are other courses that talk about the scientific revolution. There is a course that is called Scientific Revolution, and there is a course that's called Revolution in Science, HPS100H1, in which we talk about Kuhn and some other development after Kuhn. So we read the whole book, and then we read some other more recent books that were influenced by it. So that's it. I mean, we actually started, if you remember, 2,500 years ago with Zeno, and we went through different eras, different ways of thinking, different issues that we dealt with. In a sense, it was already, I mean, under the new paradigm of thinking about science. So I tried to convince you that it's important to look at Leibniz and Newton as religious people doing science. And it's not that it's not science, it's the best science in a sense, or the best natural philosophy of the time. That magic, I mean, was not necessarily, before magic was considered something irrational, and with the new history, I mean, magic is actually considered as one of the factors that influence, I mean, the development of modern science and so on, and so forth. So these things, and looking at Zeno, not looking at Zeno as someone like that he didn't know, you know, modern math and so on. It's looking, trying to understand Zeno in his own terms. I mean, as someone who's highly intelligent and works under a certain paradigm, if you want, and to try to not to be anachronistic in looking at the history of science. It's much more complicated, it's much more messy, much more, in a sense, irrational, according to the positivistic rational, I mean, consideration and so on. So, but this is, I know that it was challenging, I know that many times it was short. It's just to expose you and to tempt you to take other courses that we talk in details about all these aspects. So I hope you enjoy. And thank you. Another thing before we talk about the exam is really important, especially if you enjoy the course, to write the evaluation. So that other students, you know, to take this course. And there is more, I mean, the faculty look at, I mean, such a courses, and the better the evaluation, the more sympathetic they are, and allow us to do these things, and so on. So please go and I mean, I know that it might take 10-15 minutes, but it's really important. And the other things that we have to talk about very briefly, I mean, is about the exam. So let me tell you, I mean, what type of exam it will be, and then there will be, we will have a review for the exam, review sessions. I will send you soon. I mean, one is likely to be next week, and the other one will be closer to the exam. So the exam will be somewhat similar to the exam, the midterm. It will be from the midterm. So everything that we covered in the midterm would not be in the final exam. There will be one question, 50% that will be essay question, 1 out of 3, so similar to the midterm. And there will be, instead of 3 short questions, 5 short questions out of 3. You have the review questions. They cover all the one that are on the blackboard. They cover, I mean, all the material that will be in the final exam. If you know well how to reply to this question, you should be, you know, you're doing well. So again, like before, it's really important to come to the review and to the, obviously, I mean, to the tutorial classes. And it's very good, I mean, to form small groups in which you talk with each other and try to, you know, negotiate the answer. You can write to us, to TAB, and We will have the reviews, I mean, session of reviews. You can come and ask questions. Any questions? Yes.
How many choices do you have for the short answer questions?
5 out of 10.
The essay format is it the same as
The same as yours. Other questions? Comments? Okay. Do you have any